Hey everyone, so today's video should be relatively fast compared to some of the ones we've had recently. I just want to make sure your template is set up correctly. You want to have the template worksheet printed out. You can double-side it if you want, or if you just want to stick it back to back, that's fine. And on the bottom half of the first side of that worksheet, it says Key Concepts Foil Method. And you should also be printing out the foil foldable. Just cut it out as the rectangle in the perimeter, and then fold the foil row towards the back of the foldable, and then fold in between the two rows of equations forward, and you should end up with kind of this little flip book. So you should have the foil topics posted outward, and then when you flip it up, you should have the equations on the inside, and you can glue the back to your worksheet or tape it, whatever you want to do. If you're confused on how it fits, don't glue anything down. We can do it in class as well. Okay, so I just wanted to walk you through that. First things first, you're going to do your warm-up exercises. Again, we're just graphing the function. The first is, actually they are both in intercept form. So you're going to want to graph those using the equations. Remember, find the vertex, and then work outwards in terms of identifying coordinate points. As we move down, you have your foil foldable, and we're gonna look at that and kind of put this together. So as we work, just try to follow along. I just wanted to really review foil thoroughly for you. So when we're looking at foil, the first box is F for first, and then outer, inner, and last. And I just wanted to walk you through this really specifically so that you are ready to go. When I'm multiplying the first terms, I'm multiplying a times a, which is a squared. So in my example below, my first terms are negative 7x and 2x. And when I multiply them together, I get negative 14x squared. Then I continue on, multiply the outer terms, a times d. So negative 7x times negative 3 is positive 21x. Then I do the inner terms. Negative 6 times 2x is negative 12x. And the last terms, negative 6 times negative 3 is positive 18. Now I need to combine all of those terms into one final answer. So I only have one x squared term, so it's going to be negative 14x squared. I have two x terms, so 21x and negative 12x together is going to be positive 9x. And then I have one constant term, which is plus 18. So that's how you foil a function. Whenever you have a quantity squared or two quantities multiplied by each other, you want to use FOIL in order to work that out. So the examples that we're going to do today talk about rewriting a function in standard form. And we know that standard form is that y is equal to ax squared plus bx plus c. And so that's an important thing for us to remember, that this is our goal. And so in order to get an x squared in this particular scenario, we need to FOIL. So y equals negative 2 times x plus 5 times x minus 8. And we need to get this in standard form. So I am going to put brackets around those two sets of parentheses so that I remember I need to FOIL first. So negative 2 times, and I can FOIL straight from here. My first terms in this example are x and x. So x times x is x squared. My outer terms, x and negative 8, is negative 8x. My inner terms, 5 and x. And my last terms, 5 and negative 8, is minus 40. Now, I actually need to distribute that negative 2 that was at the front to all those inner terms in order to account for it. So I'm going to multiply negative 2 times x squared is negative 2x squared. Negative 2 times negative 8x plus 5x. So these are like terms. So I'm going to combine those first, which is a negative 3x So negative 2 times negative 3x is plus 6x. And then negative 2 times negative 40 is positive 80. So now that I'm looking at this function, is it in standard form? I have a x squared plus b plus c. So I'm all set. I am in standard form. So if you're a person who doesn't like vertex form or doesn't like intercept form, and the equation bothers you that you have to use the h and the k or the p and the q, and you just want to use good old-fashioned standard form, the very first thing we learned, you can in fact turn your functions all into standard form by foiling. It just is an extra step. So our next example says change from vertex form to standard form. Again, our goal is standard form, y equals ax squared plus bx plus c. And this is a similar equation, f of x equals 4 times x minus 1 squared plus 9. I would say the key difference here is that the x minus 1 squared is not written out as two quantities, and we need it to be. So I need to rewrite this as 4 bracket x minus 1 times x minus 1, close my brackets, and plus 9. Right? Because I need two sets of parentheses in order to FOIL. So now I can do that. 4 times x is x squared. My outer terms, x times negative 1 is negative x. Inner, negative 1 times x is negative x. And last terms, negative 1 times negative 1 is positive 1. Close my brackets and add 9. I can combine these middle x terms. So 4 times x squared minus 2x plus 1, and then plus 9. I do need to distribute. Oops. Sorry, that's not working the way it usually does. So I need to distribute, and I can do that through, I'm going to move over here. So 4x squared minus 8x plus 4, and then I also have to include that plus 9 that was on the end. So I can combine plus 4 and plus 9, and that's going to be plus 13. 4x squared minus 8x plus 13 is in fact in standard form, right? That looks the same as ax squared plus bx plus c. So those two functions really gave us a sense of when you would use FOIL to simplify a function. And your daily homework quiz. This is the very end of our video. Write the quadratic function in standard form, so please go ahead and do 2 of those examples on your own, FOIL them out, and write them in standard form. And then number 3 says find the maximum value of the function. Remember, you can find the maximum by looking at the vertex. So whatever form you decide to work with this function in, as long as you're finding the vertex, you will be all set.